Alright, so here are some common laws of exponents. So the first one we have is x to the m times x to the n equals x to the m plus n. So in the same way, if you have x to the m times x to the m again, that's going to be x to the m plus m, which is x to the 2m. And next we have the opposite, which is x to the m divided by x to the n, which is x to the m minus n. So opposite, instead of addition, it's subtraction. So multiplication is associated with addition, and division is associated with subtraction. So now what if we exponentiate an already existing exponent? So if we have x to the m to the power n, we have x to the m times n. So if we have x to the m to the power m again, you'll have x to the power m squared. And now if we have xy to the n, that's just going to equal x to the n times y to the n. You just basically distribute the exponent to both variables. And now we have x over y to the n, and that's going to be the same as this, except it's division. So you distribute n on both the variables. You have x to the n divided by y to the n. And now here is where it gets a little interesting. Anything divided by 0 is going to equal 1, except 0. 0 to the power 0 is not 1, but anything but 0 is going to be 1. So you could have negative 5 billion whatever to the power 0, it's still going to be 1. You can have 15 trillion to the 0, it's still going to be 1. And then we have x to the negative n, which is going to be 1 over x to the n. And some misconceptions about this is that people think, let's say we have 2 to the x to the negative n, they think it's 1 over 2 to the x to the n, but that's not right. You can only take the variable that it's attached to. So if we have 2x to the negative n, this is going to be 2 over x to the n. And same way, if you wanted to do the thing before, we would have to do 2x to the power negative n. Then we have 1 over 2 to the power x n. And here. Okay. And then now the last one is x to the power m over n, which is just going to be it's going to be m root, and then inside is x to the n. So when people have x to the power 1 over 2, we can replace m with 1 and n as 2. So this is going to be x. And we don't need to put anything because that signifies that it's 2 if there's nothing there. Okay, now let's do some examples using these laws of exponents. So here we have 5 to the 4 times 5 to the 7. And since the bases are the same, we can just say that 5 to the 4 times 5 to the 7 is 5 to the 4 plus 7. So 4 plus 7, which is going to be 5 to the 11. And then the next one we have is the same thing, but instead of 5, it's k. So k to the 8 times k to the 3 is going to be the same thing. So k to the 8 plus 3. So k to the 11. And the next one we have is division instead of multiplication this time. And if we remember, division is associated with subtraction. So this is going to be p to the 7 minus 3. So this is p to the 4. And then the fourth one we have is exponentiation. So p to the x to the power 3 is just going to be p to the 3x. We just multiply these together. And then this one, remember, don't get tricked. So c to the negative 2 is, this negative 2 is only being affected to the c. So 2 is going to be in the numerator, and c is going to be in the denominator. If this negative 2 is attached to this, then this would also be in the bottom. But it's not, so that's why c is the only one at the bottom. And then here, we can replace, if you remember, x to the m over n equals m x to the n. So same way here, if we replace m with 4 and n with 9. We'll get c, let me box in these answers fast. We'll get c to the 9, and outside is 4. Okay, now let's do some factoring with the laws of exponents. So the first one we have is 6 to the n plus 2 minus 6. And since there's an n plus 2, I know that this is going to be 6 squared times 6 to the n minus 6. And now we have something in common in both the terms. We have 6 that's common. So if we take out 6, then we have 6 times 6 to the n minus 1. Because if we take 6 out of negative 6, then we'll just have negative 1. And since this is 6 squared, if we take out 1, this is going to be 6 to the 1. So that's why just 6. And then 6 to the n doesn't get affected because it's one term. So that's why it's 6 times 6 times 6 to the n minus 1. Okay, and that's our answer. And then the next one we have is 4 to the x minus 25. So the first thing I see here is that this is actually a difference of squares. Because I know 4 to the x can be rewritten as 2x squared and negative 25, or we can just say minus, and then we know that 25 is 5 squared. So this can be written as 2 to the x plus 5 times 2 to the x minus 5. And that's the same thing as 4 to the x minus 25 because it's a difference of squares. And now the third one we have is 7 to the n plus 7 to the 3n. We don't really have to do much work here because 7 to the n is what's common in both terms. So if we take out 7 to the n, we'll have 1 plus, and since we took out 7 to the n from here, this 3 is going to be a 2. So we'll have 7 to the 2n. Okay, now this last one is a little trickier. So if you know how to do a binomial expansion, you know that a minus b squared equals a squared minus 2ab plus b squared. And if you look closely, this is actually very similar to what we have here. So we know that because 25 is the same as 5 squared and 4 is the same as 2 squared. So if we replace 25 to the x with, if we just say a equals 5 to the x and we say b equals 2, we can replace this and it'll still be the same because let's put this in here. So a squared, so 5x squared minus 2, and then a is 5 to the x, so 5 to the x, and then b is 2, so 2, and then plus b squared, which is 2 squared, so 2 squared, and if we simplify, we'll get 5x squared, which is 25x minus 4 times 5 to the x plus 4. So we can just say that this is what's this. So, and we know that a is 5 to the x and b is 2. So we can just say a, so 5 to the x minus 2 squared is the factor of this. Okay, now let's simplify using these laws of exponents. So this first one, we have 6 to the m plus 2 to the m, all divided by 2 to the m. So we know 6 to the m can be rewritten as 3 to the m times 2 to the m plus 2 to the m divided by 2 to the m. And now we have something common everywhere. On the first term, we have 2 to the m. In the second term, we have 2 to the m. And in the denominator, we also have 2 to the m. So if we cancel everything, we'll be left with 3 to the m plus, and 2 to the m divided by 2 to the m is 1. So we can just say this is the simplified version. And now this one, we have 5 to the n plus 1, minus 5 to the n divided by 5 to the n. And we know that 5 to the n plus 1 means 5 times 5 to the n minus 5 to the n divided by 5 to the n. And same thing like last time, like here, 5 to the n is common everywhere. So if we divide by 5 to the n everywhere, we'll be left with 5. And then 5 to the n divided by 5 to the n is going to be negative 1 because there's a negative sign here. And 5 minus 1 is 4. And now this last one, we have 6 to the n plus 12 to the n divided by 1 plus 2 to the n. So 6 to the n, we can just leave it like that for now. And we have 12n, which can be rewritten as 6 to the n times 2 to the n divided by 1 plus 2 to the n. And on the numerator, we can take out 6 to the n times, and 6 to the n divided by 6 to the n is 1 plus, and if we take 6 to the n times 2 to the n, and if we take this out from here, we'll just be left with 2 to the n divided by 1 plus 2 to the n. And we see that this right here, and this right here is the same. So we can cross this off, and we're left with this right here. So we have 6 to the n, and then that's it.